Good morning and welcome to another Haskell Kata. I will do something different today. Last video I said I would continue the bowling game Kata, but I got a bit tired of it. I experimented this weekend with discovering more laws and rewriting the interface to make it easier. It didn't get very far. It wasn't too interesting, I guess. I didn't record it, so I'm sorry. I might redo it, revisit it at a later point in time, but let's switch it up and discover a new one. As you can see, I took the Christmas lights Kata. I have the link in the description. And the Christmas lights Kata, it said at the beginning, no peeping ahead, which is usual for a Kata, but I really didn't, so this might be another exploring, stumbling video. But let's just do this and see what happens. Start to stumble. It is an incremental kata to simulate a real business situation. Work your way through the steps in order, but do not read the next requirement before you have finished your current one. Well, okay. The Christmas lights kata is about a holiday house decorating contest year after year. You decided to deploy 1 million lights in a 1,000 by 1,000 grid. And because you've been especially nice this year, Santa has mailed you instructions on how to display the ideal lighting configuration. Lights in your grid are numbered from 0 to 999 in each direction. The lights at each corner are 0, 0, 0,999, etc. The instructions include whether to turn on, turn off, or toggle various inclusive ranges given as coordinate pairs. I remember this from a adventure Advent of Code instruction. Each coordinate pair represents opposite corners of a rectangle inclusive. A coordinate pair like 0, 0 through 2,2 therefore refers to 9 lights in a 3 by 3 square. The lights all start turned off. To defeat your neighbors this year, all you have to do is set up your lights by doing the instructions Santa sent you in order. Oh, this is interesting. So we are... I'm not sure if I'm going to do this test-driven even. Let's just explore what's happening. Examples. Turn on 0, 0 through 99,999 would turn on or leave on every light. Toggle would toggle the first line. Okay, yeah. Turning off the ones that were on, turning on the ones that were off, and turn off. This would turn off the middle 4 lights. Yeah. So we have 3 instructions, turn on, toggle, and turn off in a full grid of lights. Instructions. I'm not sure where I should stop peeping ahead. Okay, this is, I'm guessing, that is part 2. Okay, yeah. Now let's follow these instructions. Let's see what's happening. Yeah, so I'm guessing we are going to have a grid, and because the question is how many lights are lit, it should be observed by the number of lights that are lit. Okay, and we need a constructor and we need 3 methods. Let's say turn on, turn off, toggle, and they have the same signature. And the signature is a a grid of some sort. We don't know yet what it will be. This will deliver us a grid. Turn on, turn off, and toggle will all give us 4 coordinates. No, 2 coordinates. and then change the grid. That means we also need a type coordinate. And if we have coordinates, we should be able to create them. Let's say 2 ints. Let's go ahead and fill that one in. And then finally we have new type. Yeah. Lights. Wait, this is an observation belonging to the grid. And this gives us the final answer. Okay, now we have the types for the interface that has been described to us. We should be able to follow some instructions, and these are turn on, turn off, and toggle. That's really naive, by the way. Why not have a list of instructions so we can just fill them in and combine them some way? That might be easier. Because now we are doing the state-based instructions. Yeah. So I have the grid. And an instruction. So we might not need a new, but if we change this to return an instruction, then we can combine instructions maybe. Driving structure. And what if we have them all give them an instruction instead? And lights then would be a combination of these all into instruction. We have a grid. We don't even need a grid then. If we have a list of instructions, this is the interface that is asked. Okay, so we might not need the grid. Remove the grid. Okay. And expose chord because we want to be able to create an instruction. Oops. Wait, then we should also expose the chord type at least. Okay, maybe you do it this way. So we have a list of instructions and apply them. Now, the final test will be, let's see, we are not yet describing laws. Let's have this as the final result. That's we're 9 minutes in already. We call lights on the set of instructions these. Okay. Wait, F. These are all chords, so trying to do it nicely, but and comma should be spaces now. Yep, those are not there. And a grid. There is no grid. Yeah, we don't have it observable then. Let's just not do this for now. We don't have an arbitrary grid. We might do it something for chords. And we don't have these signatures. Well, let's add them for now. Dirt. And then we have the chord here. Yeah. And finally, these laws, they are empty. Can we think of a basic test? Well, this will most probably fail, and the failure will give us the result. Why is it not reformatting? Oh, probably because I still need to add the type applications thingy. Yeah. Yeah, I don't know what to do with this, so I'm leaving it for now. And this one doesn't need this. Okay. And now we have to import everything. The template is not saving me time, I'm guessing. If we have a chord here, a chord, there is no observability. So let's not do this. There is just equality in chord because it's a really actually some kind of a new type. So for now, let's keep it there. Oh, and I also want to chord then. We don't have this law. So for now, and these we can add all to Kata. we not export chord? Ah, we did not export the type constructor, of course. And it's not observable, so let's do this, and I want to have mono vars because I want how did it work again? Mono vars, mono vars with type. Mono type needs a yeah, mono vars is the correct. Ah, should be a list of strings. And now this should be here. Okay. Remove all redundant imports. Finally, we have something, and we have errors. Okay, we define the interface, implement something. Implementing something is, okay, what does it mean to turn on? Because now we have to, well, these are constructors for instructions, so this we can do still. Then we have maybe 3 different instructions. The turn on, the turn off, and the toggle. Oops. I'm having the delay thing again. I had a few days earlier. And chord also is a constructor. So at least we implemented the interface, and now I have one single function that should do everything, and we didn't implement it yet. What if we follow instructions and have an empty list of instructions? Then the result should be 0. So this isn't even a property, but let's copy this for later. If we have an empty list of instructions, it should always give us 0. Okay. Now that's easy to fix. Lights. Return 0. Yay. Okay. And the final result also, everything works. Ah, we fixed it. No, this test, of course, should not succeed. And we have some requests to create arbitrary instructions. And should it be observable? No. Is there a normal form of an instruction? I don't think so. I think an instruction will also be like a coordinate combined. Is that so? I'm thinking if you want to combine 2 instructions, there might be more to it. Let's for now derive equality and ordering, so we have at least that. And finally, so it's good as is. Oh, wait, instruction I guess. And make an arbitrary instance. Well, yeah, isn't it variable? Let's say choose one of the constructors. No, it's not choose element. Yeah. Oh wait, no. I want to have something for a list of arbitraries, or a list of gens. One of. And then we have turn on with some arbitraries. It's one of. Okay. Turn off and toggle. Okay. Now we have something. What if we have a turn on for, what if the only thing we have is a turn on instruction, then the result would be the number of lights that, the number of squares in that grid, I'm guessing. So if we have a 0 to 99999, it will be a million. We do have a million lights. Oh. So if we have any instruction, just one, a single turn on, that would be area of chords. So it's not like this. We have an instruction. Oh, even worse. No, we need two chords. And those coordinates, well, this needs to be a property. We have to order them, so we have to say the top left is the smaller of them, and the top right is the other one. And if we have then the instruction the single instruction to turn on this, then the result should be the area between two coordinates. Let's say the area between two coordinates is the x, yeah, the x's and the y's. Can we inspect this? No, not yet. Let's do this then. Get X of the top left and this bottom right. And then the get Y of those two. It said it does give us top left and bottom right, always. So we are guaranteed. Yeah. The opposite pairs. So it's never bottom. Oh wait. Opposite corners. It doesn't say that they are in order. It doesn't even say that it's top left and bottom right. It could be top right and bottom left. So, well. We don't have to order coordinates then. Let's say that we have the X of the range, that would be the minimum of the, okay, this is left. This is the minimum of the axis. We have right, that's the maximum of both those two. And we have bottom and top. Top is minimum again. But then for Y. And if we say turn on between A and B, the area result should be right minus left times bottom minus top. Okay. This is true, this is a fact. Let's also define get X, get Y. And those are observations on coordinates. Wait. Okay, then we have these. I have to import them. It's almost time. What's happening with this one? Oh, I need to add property. Now it can run the property test. It will see the error because we need to have get X and get Y, but we are not done yet. Okay, but this looks like a nice first test. And as I said, only half an hour. Time is up. I will continue exploring tomorrow. I'm not sure if you see this video right now because I also would have to edit it. So I hope you enjoyed this. I hope you are ready to go on with me. I will see you in the next video. Have a nice day.